following on from what Anne-Marie and Julie were talking about, I was going to kind of focus a little bit on the actual practical application of some of this stuff and sort of take you guys through our experience on a few recent projects, looking at the background from a sort of designer's point of view, why this is important, how we've tried to factor the principles of well into design, and then if you'll oblige me, I'll take you through a few recent project examples looking at different areas around thermal comfort, around daylight and ventilation, and the implication for those. So, starting off, just thinking a bit about the context for this. Health and well-being, as we've sort of talked about already, is quite a key area of focus now for the industry. It's something that's sort of grown over the last probably 4 or 5 years. A lot of people really interested in what it means. A lot of people are starting to understand the value of healthy buildings, and it brings a lot of terminology into the mix that occupants and owners and residents can relate to. It's not just sustainability and a confusing myriad of terminology there. It's actual tangible things about how people experience their space, the quality of the internal environment, and that's now starting to influence what we have to consider as designers. Hand in hand with that, and by far and away, I think the biggest issue, certainly in London, is air quality. And as Anne-Marie sort of talked about before, this is a big issue both externally and internally. I'm particularly concerned because I work just off Farringdon Street, and that is not a pleasant place to bike to work. But it's a problem right across London, and I'm assuming you guys have probably seen the kind of articles that appear usually second or third week of January, highlighting how rapidly places like Oxford Street and Old Street have exceeded their annual targets for NOx emissions and other limits. So this is a big, big problem, and there's a lot of existing building stock and a lot of new building stock where we look at passive design solutions and trying to encourage natural ventilation and understanding how the external environment impacts on the internal. So the air quality side of things is quite key in that regard. And finally, all of this translates into the occupants and the ideas around recruitment and retention, the cost associated with getting staff in and keeping staff in. We're in a volatile market as it is at the moment, so there's a lot of movement of people. But the cost of bringing in new staff and trying to retain them, trying to entice them to come to you rather than to your competitors, a lot of the work environment is key to the people's decision, not just like where am I going to work, but what kind of office is it and what's the internal environment like. Particularly in the young professionals, there's a lot of awareness around the importance of being active at work, having standing desks, being healthy and fit. Excuse me. He says, coughing at the perfect time. And this is driving people's decision about who they want to work for, almost as much as the salary, the location, and the opportunities that come with it. And this is backed up by both sort of the press and a lot of industry standards that reflect on how you can kind of engage your employees and promote the work for them. So what does this mean for the built environment? Well, as a bit of background, I'm not going to delve too much into this because this has already been talked about quite a lot. But the first thing for us in the UK was when the UK published their report, the UK GBC published their report on health, wellbeing and productivity. And this brought the issues to a lot of people's attention. And it was building on the work that Delos and the IWBL had done, and kind of promotes the ideas around well and what that means. And kind of this has now sort of made it quite common terminology. It's raised a lot of questions for people and made it quite a key point of discussion. UKGBC did their report in September 2014 on offices. They then followed that up in February of this year with one on retail, and then in July of this year with one on residential. This is now permeating pretty much everything we do in the industry in terms of new build design. So everybody is kind of aware of this and what it means. So as a result, we're starting to look at going beyond what we currently do, starting to look at how this affects existing properties, what the situations are in our current buildings, and how can we improve these. What it means is we're now having a much greater focus on the end users for the purposes of design. Rather than ticking boxes for standards, for planning, for certification, we're starting to think about how spaces are going to be used, what that means for the way we need to design them, the flexibility we build in, as well as the sort of the health principles, the well-being principles, and the idea about how that can impact on productivity and morale. Translating all of this operational focus into kind of tangible metrics for clients and people who are commissioning new buildings so they can understand what the impact is for them. Staff are key on this. You've seen that graphic before. It's a great one, and I think it's one that's probably been responsible for a lot of the changes that we're starting to see because people suddenly realise how important their staff are. In some cases, this translates into slightly gimmicky approaches to try and bring people in. But a lot of it is translating into the idea of what's the office environment? What is the experience we have within our built environment? We spend 90% of our lives indoors. Most of it is in our home and in our office. The home is completely in our control. We can do what we want with it. Our office space, less so. So how do we make those environments more enticing for people? From a design perspective, you always have this trade-off between what can you actually put in the space, how do people perceive the value of that, the impact on them, what does that mean in terms of my comfort, my productivity, my feeling being here, and what's the cost, which is always the question the client comes back to. Conventionally, you might think about this in terms of HVAC design. We're looking at a ventilation strategy maybe, and we're trying to decide, are we going to have manually opening windows where the people will get up and they'll open the window if it's too stuffy or if it's too warm? Or do we want automatic controls and actuators so they'll open at the right time to ensure that the environment is always comfortable? You've got two different physical solutions. There's very different perceptions from the occupants, and actually the level of control and their perception of that level of control is quite key to comfort and how that's viewed, more so than the actual temperature in the space necessarily or the air movement. And the two solutions have very different costs, and there's different management requirements. So what does that mean for the developer or the client in that space? These kind of discussions and the trade-off between these three principles is starting to extend beyond quite tangible things like that and more into aesthetics and into the mind and into the behaviour and how that reflects on the environment we're creating. So what's been the response in terms of health and well-being? Well, the latest version of BREEAM has a pretty comprehensive 22 credits. This is stuff we're all familiar with and we all think about on a day-to-day basis when we're doing these kind of jobs. It's air quality, it's comfort, it's acoustics. But then when you compare that to WELL, which has 102 credits, you can see there's quite a step change here. Now, as Julie mentioned, there's a lot of overlap with what BREEAM does, and as Anne-Marie mentioned, there's a huge overlap with LEED as well, for those that are familiar with that. But there's also a lot of new stuff here. And I know from going out and talking to our clients and our collaborators, trying to explain what some of these principles mean, why it's important to design teams is quite a challenge. And what I would say is that what sits behind the WELL standard is a huge amount of information and research and work that's been done by Delos over the previous 8 years. There's a whole load of what are called wellologies, which take each of the topics and expand on the science behind it. And if you look into some of these, there are some amazing statistics and graphs and data and research that shows you how much the change in CO2 parts per million in an office space would affect people's rational thinking, their ability to make decisions, their productivity in the afternoon. If you start putting data like this in front of clients that are trying to build highly productive offices or very creative work environments, they suddenly start to see the value of all of these elements. So there's a lot of thinking about not just what the standard wants, but what that actually means to the end user, to the people running the building, and to the companies that are going into them. So talking a little bit about the idea of certification on this and what it means from a design and in particular from a simulation perspective. The first step has always been for us to kind of look at the REBA approach, look at our concept design, develop that through, get it built, get it tendered, etc., all the way to the point where we hand it over and then we walk off and we go do something else. With WELL, there is a much greater focus early on, and you have to incorporate the core concepts right at the start of the design process. The registration, the pre-assessment are quite critical to understand the form, the internal layout, position of cores and things like that. And for us as designers, we need to be guiding the rest of the team on that. But for us as simulation engineers, we need to be thinking about some of these ideas right at the earliest days. So whilst Julie mentioned that roughly half the credits relate to M&E, there's a similar proportion, albeit not exactly the same credits, that relate to simulation. And while most of the certification is based on sort of in situ testing or documentation, there's a lot of stuff early on that we can influence and we can demonstrate the value of the credits or the impact of the credits or the impact of the design on whether the credits can be achieved or not. So this means we start to look at the importance of daylight, of acoustics, of ventilation strategies, that sort of stuff, really, really early on. And we continue to evolve and iterate this throughout the design process. And in particular, continuing to engage with the staff afterwards. So that the analysis we've done on day one and the influence that has had all the way through the design and construction process actually delivers a better performance in the building, because it's that performance at the end that's going to get tested. That's what's going to get you the certification, not the simulation you did really early on or the design documentation that goes behind it. So in terms of the process, there's very much a focus on the quality of design, enabling a healthy operation, and promoting behaviour change with the occupants. The three elements that we've talked about before in terms of documentation submission, post-occupancy testing, and the recertification process, it's arguable that none of these aspects require any kind of simulation as part of the evidence. But all of them need to be thought about early on. And as a result, simulation analysis plays a really significant role much earlier in the design process, I think, than we are used to. We should be looking at how air moves through the building, how the lighting is behaving and what the comfort is at REBA Stage 2, REBA Stage 3 when we're developing our concepts and our layouts, rather than trying to do it at Stage 3, Stage 4 as part of a building regulations sign-off or a BREEAM design stage submission, for example. So we sort of talk about the idea of having a lot of consideration of what needs to happen in the building at design stage, assessing the impacts of that and trying to map that through into an equivalency in operation. And ensuring compliance with the post-occupancy testing is quite challenging. So thinking about how we can model that. If we need to achieve certain air quality metrics on when the building's in operation, what are the factors that might influence that from when we complete the building and hand over to the point where people are in it and using it? Things like sensitivity and parametric analysis start to become quite key because we don't know for certain exactly how many people are going to be in that space. If the client says it's 1 per 10, and then a tenant moves in and decides it's going to be 1 for every 6 square metres, what does that do to your design? What does that do to the levels of CO2 in the space? There's going to be more furniture and equipment. What does that do to the VOCs? How do these little changes in terms of layout and space usage impact on things? And what can we do from an analysis perspective to ensure that we're not compromising the certification at the end? The whole thing becomes very, very collaborative. We need to engage much more with occupants and with building owners, and we need to move away from default assumptions and templates and standardized calculations and actually start to model in a more bespoke manner that's attuned to the building. And this will impact the design approach. Traditionally, it's been a very siloed. The architects and structural engineers will make sure the building stands up and the core and the facade do what they need to do. The building services guys come in and fit out the heating, the vent, the AC. 9 times out of 10, we don't even think about fixtures, fittings and furniture. That's somebody else's problem. And lighting will get dropped in. Sometimes it will be ambient, sometimes it will be task, a combination of the two. There's probably an architectural requirement in terms of how the fittings are going to look and how they work. That kind of siloed approach isn't going to work for well, and it's not the sort of thing we need to be doing if we want to have healthy and productive buildings. We need to be thinking about the experience in the space. Air quality is a function of the building, the systems, and the fixtures, fittings and furniture. So we need to consider all three of those really early on because it's quite a fundamental precondition for well, and you're not going to get it if you're not considering all these ideas. Similarly with things around thermal comfort, around lighting levels. We've all worked on jobs where it's been core and shell, and you've got an idea of how the office is going to be laid out and you've modelled on that basis. And then a tenant comes in and they partition it in a completely different manner, which means that the ventilation system's not working because you've got supply in one zone, extract in another, and the two don't connect. Or you've got lighting and you've got a partition wall right down the middle that cuts through it. We need to move away from that kind of isolated approach and try and think about the whole process and the experience. So this is kind of our start for 10 on what we think can be simulated, and builds a little bit of what Julie was talking about, I think, in terms of the key concepts from well and the opportunities for these. Now, some of this I think we can do currently, both within the virtual environment or with other tools as well. And a lot of this I think is stuff that we don't really do either. For the most part, simulation will be a little bit of load sizing, some Part L, the odd bit of AM11 or something like that for a BREEAM assessment. But we don't really get into the air movement within the space unless it's a very passive design combining facade and atria and that sort of stuff. We don't look at specifics within the zones. We might have a perimeter core segregation in an office, but we never look at individual desks or the circulation areas. And thinking about things like acoustics and materials and the fit out in the space. How is the furniture and the partitioning and the false ceiling going to affect your air quality, your acoustics, and the experience of the occupant and how they feel? And what are they going to do in terms of lighting and reflection on the surfaces? So there are opportunities here, I think, way beyond what we're currently doing. There are some limitations, of course, as well. Quite often there's a challenge around the feasibility, fundamentally, of doing all this sort of work. We often look at very high level, multiple zones, but very much sort of core shell or office, classroom, retail type spaces. There's very limited metrics as well. And I think this is something that Neil and Sarah will probably come on to talk a bit more about, but there's a lot of opportunity to combine the basics of temperature and humidity and CO2 and look at proxies to see, well, actually, how can you relate temperature and CO2 to productivity? And how can we then translate that back to the client as an occupant experience metric? There's also a lack of resource, and tied with this is a lack of cost or willingness to spend money. Quite early on, we'll have some very high-level calcs. It's usually just to check that you're doing what you need to do for planning. You'll then have your kind of certification assessment. But more often than not, an SBEM calc might be a day or two's worth of work. To look at all the stuff I've put up on screen, you might be looking at a week or two's worth of work. And it's a lot more iterative. It's about looking at 2 or 3 simulations for each area to say, well, this is what's likely to happen, but if you have a few more people, or if it's a slightly different environmental condition, then this is the sensitivity of it, this is the significance of the change. And that's the sort of stuff that we're not really doing at the moment, but it's a big area of opportunity. And actually, it's the sort of thing that can put us, as building simulation engineers, right in the middle of the design process as the key pivot for what's going on. What we need to do is show the value to our clients in terms of the product they get at the end of the day and the service that we give to them. So I thought I'd take you through a couple of examples. These are projects we've done recently that have a very traditional approach, and then for one reason or another have become more of a well style of approach. So the first of these is a coffee shop. Very simple, kind of quite standard coffee shop. You've got big seating area, there's a counter, and there's a back of house. Conventional design approach was based on load sizing. So we look at how many people are in the space, how much lighting, how much solar gain, et cetera, et cetera, et cetera. Worked out that they needed 3 fan coils in the ceiling. And they were located in a fairly arbitrary manner. And there was ventilation provision based on the number of occupants. And that was about it. It's pretty standard, roll it out. There's 100 sites like this built every year. So the design team churn it out quite rapidly, pretty standard approach. Sometimes all of the sites will obviously have pile. There'll be an SBEM calc that goes with it. That'll split it into 2 or 3 zones. Sometimes there's a BREEAM requirement from the local authority because you're building in an area and they want a BREEAM assessment. Quite often that's fit out based. There might be a bit of an assessment about, well, how many hours over 28 degrees are you meeting thermal comfort, et cetera, et cetera. When you've got big AC units in, chances are you'll meet that, and actually there isn't much more to it. But then the client found during operation that the customers weren't comfortable and the staff weren't comfortable, and they were getting a lot of adverse feedback. And when they looked into this, what they found was that on the summer days the staff were really, really hot. They were working behind the counter, they got coffee machines, they got panini machines, they got 3 of them in a cramped space, and it was way too hot. They got the air conditioning turned on to maximum and they were still too hot. And because they got the air conditioning turned on to maximum, half the customers sat beneath it in the middle of the coffee shop were too cold. So there's obviously something quite fundamentally wrong in the way the space has been designed. But how do we assess that and how can we make that change? Well, what we did was we took the coffee shop and we said, well, what are the key areas? Where are people sitting? What are the factors in terms of orientation and everything else? And we chopped the model into pieces. And we took what was originally a 3 or 4 zone SBEM model, and we had about 18 zones, I think, in plan in the end, and 2 or 3 levels across the space. So in the seating area, we had a low-level bit, which is where people were sat, and you get the odd laptop here or there, but not too much. You had a high-level bit, which has got the lighting and the fan coil units. Behind the counter, we actually split it into 3 levels because you've got refrigeration at low level, you'd got coffee machines and the staff at mid-level, and then you'd got the MVHR and the lighting and stuff at high level. And it meant that we could locate every gain within the space it was sat. And we got a load of operational data and we said, what's your biggest day for sales? What's the hottest day of the year? And let's combine those 2. And we looked at how many coffees were bought per hour, and we turned that into a proxy for how many people are in the space. We looked at how many paninis were made per hour and turned that into a proxy for the operation of the equipment. And we modelled everything within this space as a single element. And what this enabled us to do was to ascertain exactly what the temperature was in each space in the zone, how many hours it was above certain thresholds, what was driving the movement of air through those spaces, and how the fan coil systems were performing. From the back of this, we were able to make recommendations about how to improve the space. So we ensured that the average temperature was never excessive, and we ensured that every space was comfortable for the period it needed to be. Now, there was a couple of exceptions to this. You'd got a very heavily glazed south-facing facade, which is why on the right-hand figure there's a few areas that get above 24 for a reasonable part of the year. This is for the peak day, actually, not the full year, but anyway. But what we found was there was a couple of key things. One was about the location of the fan coils. They were dotted throughout the seating area rather than being specifically located to the facade that was going to get a lot of solar gain, the counter space. The controller was on the wall to turn it on and off, and that was programmed with set points and hours of operation, which seems pretty logical. The temperature sensor was mounted to the bottom of the fan coil unit, which meant that if that zone was comfortable at 24, the fan coil unit would turn off, regardless of what was actually happening in the occupied zone beneath it, or the zone adjacent where all the staff were working behind the counter. And that one fan coil unit there was controlling the other two next to it as well. So there was a few recommendations around relocating the units, moving the sensors to the occupied spaces, having a sensor for each fan coil. And a lot of this, when you look at it, seems quite common sense. But it's the kind of stuff that we never really think about when we're designing a building, because we'll say the peak gain is 25 kilowatts and we've got 30 kilowatts of cooling. That'll be fine to keep it comfortable. So the second example, looking at lighting this time, just talking about the kind of process here more than a specific kind of solution. But this is an office project we worked on in Brazil, as you can tell from the Portuguese labelling on the drawings. Very conventional approach, looking at the balance between natural and artificial light, focusing on using daylight and radiance modelling to advise on window sizing and location, trying to bring as much natural light into the space, but also thinking about what the impacts are in terms of glare, ensuring that people can still use their desks and the computers in the way they want to. Having a focus on the lighting controls, getting a balance between ambient and task. So we looked to engage with the lighting manufacturer, looked at the distribution of lux around the space and how that was controlled for different times of the day and different occupants. And this was all great for kind of energy use and illumination. What it didn't really look at was mood and productivity. And this is a much poorer version of the graph that Anne-Marie had up earlier, but it shows the same idea that there's a variance throughout the day in terms of how productive we are as individuals. And there's times a day where a little bit of extra blue light would help boost that productivity, and there's other times a day where a bit of red light would help calm us, let us relax a bit more and switch off before we go home or before we go to bed. And this isn't just a function of ambient lighting, this is a function of the screens we use as well. You can download apps for your phone or your tablet or your computer that will change the colour temperature on that. So we looked at how we can shift the colour temperature on individual lighting within the space, targeting changes that will occur throughout the day that could be fine-tuned for the individuals. You can have an app on your phone that controls your desk light, and you can say, I'm going to be in the office at 8 in the morning, I want to take lunch at 2, and I'm going home at 5. And it will shift that curve for you, and it will vary the light throughout the day to align the way you want to work. Your colleague next to you can have a completely different profile for their task lighting that suits them and for their computer. And this kind of highlights the importance of not just thinking about the balance between natural and artificial light, but bringing this home and into the individual space and the individual experience of the users. There is potentially a trade-off with energy in terms of the fact that the lighting becomes a little more intensive and more focused. But actually, if you're changing the shift from ambient to task focus, you're getting a balance with the daylight as well, and you're varying the colour temperature. I think you're probably going to find that you're on a par with most other solutions. Finally, to talk a little bit about air quality. I highlighted early on this is the biggest issue for me personally, and I think for us we found as a company as well, it's one of the biggest challenges with the WELL standard and with doing anything in London in particular. This is a recent restaurant project where we were trying to understand whether we could get a naturally focused strategy to try and be energy efficient and as passive as we can. So we looked at the air movement within the space. We were looking at macro flow modelling in IES, as you can tell from the image, taking the CIBSE Guide A criteria as our basis, linking this back into BREEAM credits as well, but sort of showing what was going on in the space, bringing air in from facades open towards the prevailing wind, using roof lights and clerestory windows to try and drive the stack effect. This seemed to work really well. We could see it was quite comfortable for a lot of the year on a bulk basis. The restaurant as a whole looked good. But we got a quite attuned client they'd had experience on previous projects where people experienced discomfort, where they were right next to open windows or right next to the kitchen, that sort of stuff. So we did some CFD modelling when we started to look at how the air moved within the space, what that meant in terms of air speeds and temperatures and comforts. So not just saying overall is the space below 32 or below 28, but actually how does that vary? And this meant that we could see the significance of different times of day, looking across the whole of a typical day in the summer and in the winter and what that meant. And we picked up on the temperature, the flow rates, the speeds, and could even look at the average age of the air, which is kind of a good proxy for how fresh it is, whether people are going to be a bit drowsy or not. But the big problem with all of this is it didn't really get into the detail of the quality of the air. Now when you look in well, and this is one of the graphics from the wellologies I mentioned earlier, these are the things that all get factored in somewhere within the air aspect in well. So things like mold and bacteria, things like combustion, fumes, carbon monoxide, cigarette smoke, none of that gets picked up in our conventional modelling. And actually, how we model that within a simulation is a really interesting question, because a lot of that is influenced by external factors that we probably don't know. It's very site or project specific. There's a lot of influence from things like furniture, fixtures, fittings, even people themselves. And all of that we don't really know at the design stage. So a couple of projects recently we've started to look at monitoring as an alternative to simulation and trying to partner that up. And actually monitoring the current conditions in people's buildings, whether it's offices, restaurants, homes, to see what's going on in the space and what's actually happening, and comparing the observations from monitoring back to the requirements from the standards. What's really interesting is that VOCs, we saw some really odd behaviour in a typical office. You get a build-up of VOCs to a saturated level overnight and over the weekend based on off-gassing from the furniture and the fixtures, fittings and everything else. When the staff come in the morning, they open the windows, the level drops because the external level is much lower than the internal. But even with the window opening and quite a nice sort of passive strategy through the summer months, the levels we were finding in a typical office were an order of magnitude higher than the target levels that come from the well standard. So this really highlights the importance of thinking about your preconditions really early on, understanding what the levels mean and what that might require. And the fact that actually if you've got a natural ventilation strategy like this, switching to a mechanical ventilation with good levels of filtration might be a better way to go. So to sum up then, because I appreciate I'm standing between you guys and a coffee, and there's probably quite high levels of CO2 in this space, so you're all quite drowsy. Final thoughts from me. Health, wellbeing, productivity are very much the new design metrics. This has got to become our new language, and translating this into something the clients can understand, that building occupants can understand, and also that our colleagues on the design team can understand. What does it mean for the architecture? What does it mean for the building services? And how does simulation support that? Very much a greater focus on occupants, and this is something that we really should be designing for, but quite often we don't know who the occupants are going to be. If you're looking at things like well and health and productivity, you can't not know who your occupants are because they're quite key. Standard design, rules of thumb, the way we do things at the moment really aren't sufficient for what we need to do. And I think we need to have a much more holistic design approach throughout the process and be involved from the very first stage right to the very end. And all of this means that there are really significant opportunities for simulation here to get involved. Thank you very much.